Hi, this is Mrs. Mahowald
and Mrs. Mathiasen,
and we are here to go through the notes sheet that you have on area and perimeter. So what we want you to do is to follow along with us, and anything that we're filling in, we would like you to do the same. So, what we're going to start with is finding out just the definition of area. An area is the number of square units inside a figure. So the first shape that we're going to look at is a square. And if you notice right here, the formula says A for area equals side squared. What that means is side times side. So we look over here at this square, and this is 2 centimeters, which means that this is also 2 centimeters. So we take 2 times 2 equals 4, and we have to remember to label, so it'd be 4 centimeters. And with area, we always say centimeters squared.
Okay, and moving on to a rectangle. A rectangle, the formula for area, most of you know length times width. Some students like to use the vocabulary words base times height. But we're going to just take the length of the rectangle times the width of the rectangle. So I'm going to plug in 5 times 2. That equals 10. And then again, our label would be inches squared.
Okay, now we have a rhombus. And if you notice, the formula for a rhombus says base times height. This is the base on the bottom, but I want you to notice that the height is going up and down, which means it's perpendicular to the base. It forms a right angle. It has to be going straight up and down. This is a side, not the height. So on this rhombus, we take the base, which is 6, times the height of 4. Oops, let me erase that. Sorry, guys. Which equals 24 feet squared, and that would be the area of that.
Next is a parallelogram, very similar to a rhombus. Again, the formula is base times height, and again, same thing. The base has to be perpendicular to the height. So in this picture, you'll notice you've got 12 going across the top. That's actually the base of the parallelogram. Some kids always think the base has to be along the bottom, but opposite sides are equal. So we're going to use that as the base because the height, which is perpendicular to it right here, is 5 centimeters. They've given you another measurement here, which is the side of the parallelogram, but we're not going to use that when we find the area. Oops. All right, so I'm going to plug in my base, 12, times my height of 5. That equals 60, and then my label would be centimeters squared.
Great. Feel free to pause the video at any time if you need to get caught up, and feel free to rewind if you didn't get something.
Because we're fun to listen to.
I'm sure you want to keep hearing this. All right, so on to a triangle. If you notice, a triangle has 2 different formulas. The first one is you can take 1/2 times the base times the height, or you may have seen base times height, and this line here we know means divided by 2. Now let's look at this triangle. As we said before, we know the 9 is the base, but the 3 would be our height because there again, it has to be perpendicular to the base, meaning it forms a right angle. So the 3 is our height. The 5 we will not use for the area. So I'm going to take 9 times 3, which is 27. Now that would give me if it was a rectangle, but we know that a triangle is half of a rectangle, so now I have to divide that by 2. When I take 27 divided by 2, I actually get 13.5, and that would be centimeters squared again.
Your answer is not a whole number, Mrs. Mahowald?
It's not. It is okay to have decimals. Not okay to have remainders, but it's okay to have decimals, or you could have written 13 1/2 centimeters would have been fine too. No
Gotcha.
Remainders with this.
All right, got it.
Good catch, Mrs. Mathiasen.
Good. All right, now a trapezoid. A trapezoid is kind of a different shape maybe you're not as familiar with. A trapezoid has one pair of parallel sides. We call those the bases. So they're labeling this as base 1 and then base 2. And then a trapezoid has a height, which just like the past 2 shapes have been perpendicular to the base. Darn it. So the height is perpendicular to the bases, okay, it forms that right angle. So when I look over at this trapezoid, my parallel sides are the bases, not these two that are not meeting they're not parallel. So those would just be sides of the trapezoid. We're not going to use those in our area formula. So the formula is a little complicated. You have to take 1/2 times the height of the trapezoid, and then you add the two bases together and multiply that times the height. So what I'm going to do is I'm just going to plug my numbers into the formula first. So I'm going to take 1/2. The height of this trapezoid is 5. And then I'm going to be multiplying that times 7 plus 4. Now, if I follow order of operations, I want to do what's inside parentheses first. So I'm going to add 7 plus 4 is 11. And then I'm going to multiply from left to right. So 1/2 times 5 is 2.5, or 2.5. And then that times 11, it's going to give me 27.5.
And once again, another decimal.
Which is okay. The label this time would be meters squared.
Nice job. And the last shape we're going to look at is a kite. Sometimes you guys may have called it a diamond, but let's look at this kite. Another kind of complicated formula, a little bit like the trapezoid. So we have 1/2. Now these D's stand for diagonals. Okay, so it's diagonal 1 times diagonal 2. Or you could say diagonal 1 times diagonal 2 divided by 2, which is kind of like the triangle. P represents diagonals. So what we have is, once again, these are sides, the 8 and the 4. So the diagonals are actually going from point to point.
Inside the kite.
Inside of the kite.
Yep.
So what I'm going to do on this one is I think I'm going to go 6 times 10 divided by 2. So what I'm going to do is I have to do everything on the top first. So I'll say 6 times 10 is 60. Just catching up. And 60 divided by 2 is 30. So the area of this kite would be 30 centimeters square. If I wanted to do the 1/2, I would have done 1/2 times 6 times 10, and I would have had the same thing. 1/2 of 60 is 30 centimeters square.
Okay, guys, so you finished filling in the area formulas and working through those examples on that side. Now, on the back side of your note sheet, it's talking about perimeter of these figures. And the definition of perimeter, let's fill that in first. Perimeter is the distance around a figure. So to find the perimeter of a figure, we want to add the lengths of all the sides. Now, I'm just going to go through the two examples with you that are in this top box, and then you guys can go ahead and work through finding the perimeter of the other 4 shapes on the back of your note sheet on your own. So if I was going to find the perimeter of this rhombus, or parallelogram, sorry, it's a parallelogram, opposite sides are equal, right? So we've got 7. If you look down here, what you could do is you could start at a certain point on the shape. Sometimes I just go around and start at the top and work my way around and add them up. This is showing you to do the 3.5 plus the 3.5, both opposite sides, which 3.5 plus 3.5 is 7, plus the 7 plus the 7 here, which you could add that together if you wanted to get to 21 feet. And perimeter is just units, it's just distance, so we don't have any square units, it's just feet. For the perimeter of the triangle, you could add up 3 plus 3 plus 5, so the 3 sides of the triangle. So 3 plus 3 is 6, 6 plus 5 would give you the 11, and then your label would just be inches. So now why don't you go ahead and try to work through the next 4 examples on your note sheet on finding perimeter of those shapes.